So
Sure,
we
if
can.
you want, wait, and let's see where we are right now. Okay, I'm just sorry about that. Okay, I'm now ready, and share this screen too. Yeah.
We can see it. Yeah.
Okay. Not me. The dependency injection screen, right? You can see it. The present.
Yes.
Okay, great. So let's get into it. Okay, so the presentation today is about dependency injection, what, why, where, and when. Before I start the dependency injection, I just a little bit talk about myself and introduce myself. I have more than 20 years programming experience, bachelor's in computers, master's in computers with minor of machine intelligence, which is a branch of artificial intelligence. Also, I have a degree in web and mobile application from BCLT, and I'm also Microsoft engineer, MCSD from Microsoft, in the branch of web application development. Titles and responsibilities that I had during my career. I work as a senior .NET developer, software architect, cloud and database administrator, programming instructor, and software project manager. And my highest title is Chief Technology Officer. I started working with View Systems since 2008, but most of my work is back end, and so that's why most of you probably haven't heard of me until last week, because I'm a backstage guy and most of my services is web services, APIs, and Azure development and administration for View Systems. The framework and language fields of work and experience that I have mainly during my career, it was .NET, C#, ASP.NET MVC, JavaScript, SQL Server, Azure SQL, Oracle, Windows Server, Web Services, Web API, Cloud Application Design in Azure. Also, based on the project that I was involved, I worked with Jira, Asana, Agile, both types, Scrum and Kanban. Node.js, .NET Core, Angular, TypeScript, machine learning in Python, and containers and Dockers and Linux server deployment. And back in the day, because I'm really old, I have some old experience in my early years of career. I worked with C, C++, PHP, Java, Enterprise edition of Java, iOS native and Android native mobile application, and also hybrid mobile application using Cordova. At that time, actually, it was called PhoneGap. And structure analysis design, Oracle data mining, and SharePoint. So this is me. Let's get into dependency injection. The most important things about dependency injection to remember is it's a design pattern, similar to other design pattern like a factory, singleton, so on. The main idea behind dependency injection actually originated in 1994 in one of the papers by Robert C. Martin, which is called the Dependency Inversion Principles. So dependency injection is not a very new idea or concept, but these days actually really is getting popular. The first time that any framework actually used dependency injection, it was in the Spring framework, is a Java framework in 2003. But the most powerful company that started getting serious about dependency injection was Google from 2007. Microsoft started adopting these design patterns for its framework around 2012 by introducing .NET Framework 4. To define dependency injection in the one statement, in software engineering, we can define dependency injection as a technique in which one object or function or module receives other objects that it depends on outside of its own code. We call those dependencies, we call those objects dependencies, and these days usually they use the term of services for that. Again, dependency injection is one of the solutions or one of the parts that is introduced by higher concept and more general concept is called inversion of control. To compare with the traditional way of programming, in the traditional OOP execution flow, so you instantiate in your code, you instantiate your object from a class, and inside that code, in the constructor or in the initialization method or function, you start instantiating the lower level objects that this object needs to do its job. The inversion of control actually makes the whole thing upside down. This way, the lower level objects gets instantiated first, not by your code, by the framework. And then the framework, when they instantiate your object, it actually gives all of those dependencies or services to your object to use. Let's use one real lifetime example for this one, outside the programming things. Imagine to feel and understand inversion of the control. Imagine you are a taxi driver. Your talent, your expertise is a taxi driver. So to do your job and make money, you need to have a taxi vehicle. So taxi is your dependencies for your job. So there is a two approach here. One approach is that you buy your own taxi, pay for the gas, pay for the repair, pay for the car wash, do everything that needs to be done to keep your car or taxi in the good shape and use it to make money. The other approach, that's the traditional approach. The other approach is that you join a taxi company. In this case, the taxi company, which is in the programming, is framework, lend you a taxi every day or every time that you want to work. The taxi is full tank, car washed, repaired, and ready to use by the company every day. And you can just get the taxi, use it, and make your money. And at the end of the day, just give the company its own cut. So this case, the company is responsible for providing all the taxi for you. That's the inversion of the control that we are talking about. So let's talk about dependency injection today. We saw that that's not a very new concept. We had it since 1994, but why these days is really important, why these days we're talking about it a lot. Yep, it's trending, picking up the popularity every day, especially the last several years, I'm sorry. And let's look at the popular frameworks that right now we are using, especially in the web application development, my expertise. So look at the backend. The backend, we have a Node.js, if you are a JavaScript programmer. if you are coming from the Python, so either you are using Django or you're using Flask, going lightweight or you're going heavyweight. Or if you are coming from the Microsoft Word, right now you are using .NET Core, which you're using C#. At the other end or front end, definitely you have seen one of these four right now. Express, Vue, or Vo, better pronunciation for it, React, all top three, they are the JavaScript, based on the JavaScript, and the Angular, which is using the TypeScript these days after the AngularJS. All of these, they use and support the dependency injection. I make two of them bold and with different color. One of them is .NET Core and the other one is Angular. The reason is, although all of these frameworks, they support dependency injection, but the others actually give you this permission to get away with it without using it. But .NET Core and Angular, not. That's technically, they are forcing you to use dependency injection. This is part of their best practice. If you are not using them, technically you are violating their best practices. So that's today's world and today's framework about how they think about the dependency injection. Okay, and so let's talk about the dependency injection in a little bit more detail. We said that this is a part of the inversion of the control. And the most important part here is using the I. We move the creation, that's the most important part. We move the creation and binding of the dependency objects outside the class that depends on it. Dependency injection needs 3 players to make it work. There is 3 parties in this design pattern. One of them is client. The client is your code. This is the code that, that's the taxi driver, technically. That it needs some stuff to make its own job. The other one is a service class or dependency class. This is the one that your client class needs to do its job. That's a taxi. And here we need a third player. We call it injector. This one usually is part of the framework, although you can write your own injector, but what's the point here? Most of the framework that they support the dependency injection, they have this one already in place. The injector is a part of the framework that's the one that instantiates the service class and give it to the client. So in the bottom of this page, you can see how they connect with each other. Clients wants to use the service, injector create the service, inject it to the client, and after that, client can use the service. And in the bottom of the page, in the right side, you can just, again, you can compare the traditional way and the DI way. In the traditional way, the main object or your object owns all of its own dependency because it instantiates all of them inside its own code. So it owns all of those. On the other hand, in the dependency injected form, the injector owns all of the instances. It just lends it to you. And after that, when you finish with it, it actually take it back. Okay, so far it was really boring. So let's just take some picture cartoon, make it a little bit fun. The first one, the first cartoon or comic on the top, technically they say the same things. That's the only joke, that is the only cartoon that I found for dependency injection. that the guy, which is your code and your class, asked the injector, the wizard, that I needed object A, B as soon as possible, dependency injection. The wizard says, sure, no problem. It instantiate all of those and package them and give it to your code. Do you see my arrow as well or not when I'm moving my arrow? Okay.
I can see it.
Yeah, okay, good. Okay, the same deal on the bottom, but in the bottom, actually, we are introducing another idea that is really important in dependency injection. Again, in the bottom, you are as a golf player, you need a club to do your golf. But we know that in the golf, we just don't have only one type of club. We have a different type of clubs, but all of them are clubs. We have a wood club, iron club, wedge club, and putter. All of them are clubs. So the superclass here is a club, or interface here is club, but there is a different variation of it. In the dependency injection, if it be implemented correctly, you, as a golf player, you just need to tell the injector, I need a club. The injector, which is part of framework, based on the resources that they have in the framework environment, and based on the resources available, and based on your job, actually can find out which type of club you need and actually give you the right one, which is in this case that we are too close to the hole is a putter. So this is the another advantage, or this is the another way that the dependency injection can help you to not overkill, not instantiate a very large and expensive dependency when you don't need it. So you are not giving a driver to somebody who needs a putter here, for example, in the golf. Okay. So let's see how we can implement dependency injection in our frameworks. Different frameworks actually have a different type of implementation, but we can categorize all of them in the three ways. We have a constructor injection, which is that's the most popular one. The one that you're gonna see that in most of the framework is the constructor injection. Also, we have a property injection. Another name for property injection in some documents is the setter injection. And the another one is a method injection or interface injection. That was the case in the golf player that we talked about in the last page. In the constructor injection, technically, when you are implementing or coding your class or the one that you are instantiating to create your own object, you know that each class in object-oriented programming, they can have a constructor function. This is the place that in the constructor, you define what dependency that you need. And framework actually give this information to the injector. Injector here is a module part of the technically your framework. And the injector, based on that, instantiate the dependencies for you. The other way is to just define this property, a public property inside your class, and with some decoratives, tells the framework that this is the place that I want injector put the reference to the dependency for me. And the third part is the method. So in the method, technically, you are communicating, your code communicating with framework and injector through an interface, a club, that last example that we have. And that club, that one has a method that method actually activates the injector. So technically here, the interface is iClub, the method is give me a club. And this is another way that we can actually implement dependency injection. Most of the platforms, I mean, the one that you're going to see in the most of the framework is the first one, but the others are actually ready to implement. If you want to implement it, most of them, they actually give you the tools to implement. Okay, so to show you in some programming languages, I use the Angular and .NET. Although you might not be familiar with these two languages, I try to find the simplest example, and I'm gonna go through it and explain. So even without knowing the syntax for these languages, probably you get the concept that how the injector and how the I here works. So in Angular, which is one of the front-end programming using TypeScript, imagine that we have a list of the heroes in the remote server, and we want to retrieve that list of heroes and just display it on the one web page. Something like that, something like this. Okay, for this one, we need a service. The service that in the real world, in the production, needs to connect to that remote server, create a TCP connection, and retrieve this data and bring it for us. Or if this data is in the database, the dependency here is the object that connects to the database and query the database for us and grab this information. So this part, dependency, service dependency class, this is the dependency. This is the part that service that we need to implement. In Angular, when you want to tell injector that this service is injectable, you are using the decorative injectable. That's the way that you tell the injector or the I framework that this service is injectable. And here, there is another thing here that we say provide in root. This technically tells the injector that we want one single copy or one single instance of this service for the whole application. If you are familiar with singleton design pattern, singleton technically is the time that you have a class, but you just want to instantiate only one instance of that class and nothing more. And this service here, as you see, this is this defining the service. We have a class called hero service. This is the service. And this service has just one method called get heroes, which is returns the heroes. Here we are not connecting to any database, or it makes this code really lengthy and hard to read. I'm just grabbing it from mock data, just importing the mock data and returning that one to make this example simple. So this is the dependency. Now let's go to the client or dependent class. This is your class. This is the one that depends to this service, depends on this service. Okay, the first part is some imports for bringing this service here or bringing the classes that they need. That's fine. Don't worry about that part. This is the template. This template is technically is a HTML template that which is rendered to the inside the browser and create the HTML content for us. And one thing that this template does, it actually look through the heroes, which is the heroes here, defined here, is the property of this class that contains all of those heroes' names and information. Look through that one and just display those inside the HTML page. So let's go to see where the dependency injection happening here inside the class of the hero list component, we have a constructor for this class. This is our class. In the constructor, as you see, as a parameter, we are defining hero service as a hero service. That's enough for the Angular framework. That Angular knows right now that anytime that we instantiating hero list component, the injector needs to instantiate this service, this one, hero service, and give a reference to that service or object to us through hero service. And as you see in the next statement, we just call the get heroes that we had in the service class to get that data. As you see, none of these code, you can see any new command or any instantiating command to instantiate the service, because we are not doing that. The Angular framework does it for us. That's the thing here. Okay, and let's go and see another. Do you have any question here before I go?
So when I have a little question here, so I just to understand a little better.
Sure.
We are defining our class, and in our class, in the constructor, we have a collection of heroes, and then you, okay,
which is empty, which is here is empty, is null value. It doesn't have any value here, right?
all we know that we have a service provider hero service,
Okay.
which we need to pass to this constructor.
That's correct.
And this will fill in our collection.
Exactly.
This .heroes is our collection. It will get all the heroes and put it in there. We don't know how it does it. We just don't.
We don't care.
And it just fills it up for us. It could get it from a database, it could get it from a cache, or it could get it
from markup.
or from a file.
Yep. That's the whole idea. That's the whole idea, that we don't care about where this dependency get that data for us.
Okay.
Yeah, we are trying to separate these two concepts from each other. So technically in the dependency injection, we are telling that your object shouldn't know anything about the dependency and how the dependency works and how the dependency gets its own data. We are creating very, very loose coupling between these two modules.
So all you know about that service is that it provides get heroes. That's all we know.
All we know that, yes, all we know that there is a service, that this service, its name is hero service, and its job, let's go back to, its job is to get the list of the services, and its method is get heroes. That's all. That's the only thing that we need to know, and that's the only thing that we care.
So, and it's a singleton because we don't, the service provider is just one object, and every time we need, we just pass to the same object. It's kind of called data store in 4D, like we just keep calling the same data store.
Correct. Yes, and it's not just because this one is just a one file, and we are getting the same data over and over. Even there is some very, very expensive resources like database connections or network connection or TCP connection. These are expensive resources, and most of the time they are limited. And most of our services or subsystem in our code, they need these resources. And instantiating of something like a database connection, you know that has a huge overhead. And always you have a limited, for example, if you check some databases, maybe they limited you or as a user to 2 or 3 concurrent database connections based on your. So in those cases, all of these things, now the injector or the dependency injector framework take care of it. You don't have to worry about those parts in your code. If you use the dependency injection in the right way.
Okay, thank you.
No problem. So everything here is clear. Can I go to second example?
Guys,
Okay.
if you have questions, please ask.
What's that?
I'm asking the team if they have any questions to ask. Because
Okay.
this is completely new for me. I never knew about this.
Yeah, yeah, that's a new. I mean, most, as I said, these days are really trending, although it's another very new concept. Okay, another example I'm using here is from Microsoft Word, ASP.NET and .NET Core. As I said, .NET Core is another framework that technically forces you to use dependency injection. And again, here we are using a very, very simple example. We just want to have a service that this service just return the current time. It's as simple as that. You don't even need a service for that, but anyhow, just for simplicity. So here we are using the one interface, iDateTime, which is like an iCloud that in our comic. And this one, it just has a one here, it just has a one property. It's called now, that this is the only thing that this interface has. Then we define our service or our dependency. We call it system date time, which implements the iDateTime or interface that we had. I don't know, everybody familiar with interface and implementing the interface or not, or skipping? Okay. So we are interfacing iDateTime for this class or this service. That means we need to implement this now here. So we are implementing the now here, and we just simply returning the date time, system date time, current time. That's the only thing that we are doing. So this one right now here is our dependency. In .NET framework, because we have a more powerful features to configure the dependency injections, we need to go one extra step. And there is a file in the .NET Core, it's called startup C#. And this one has a method, it's called configure services, which is you need to define for injector that which service you want to inject. It's similar to injector decorative that you saw in the Angular, but we are doing it here in a different way. As you see, this statement that is highlighted, services at singleton, iDateTime, system date time, telling the .NET Core framework that we have a dependency, that we want just one instance of it at singleton, telling the .NET Core we just want one instance of it. The communication happening through the iDateTime interface. Go back to the our comic is technically is the iCloud. And system date time here is our service. Is one of those features, iClub, iPutter, Putter Club, or Wedge Club, or Driver Club that we're talking about. Now let's go to our code. In .NET Core, if you are programming ASP.NET, most of you can see something is called controller. Don't worry about that part. This is the class that we have. This is our class. And you see that, again, this is the constructor here. This is the constructor of the class. Again, in the constructor of the class, we are saying that we need the date time, and we call it date time. And then when we instantiate in this class, injector, based on this information, create a singleton from this class and inject it to us, inject it to datetime variable. So technically the datetime, we put the datetime variable to one of the private properties here. And then in the rest of the application, rest of our code, we can use it. As you see, datetime now here, technically we are using the service. Again, we didn't instantiate this class directly in our code. You don't see any instantiation or any new command, but the injector does that for us. Any question about this example? Anything that is not clear?
This is a bit more difficult for me to understand the last.
Yeah, it's more complex, yeah.
It seems like you have a generic way of defining singletons and services, and then telling.
Yeah, go ahead.
Yeah, so it's kind of a very, like you can create different services like that, I'm guessing.
Yeah, .NET framework is more powerful. It can, you can control the scope, you can control the type of communication. So a little bit, we have more configuration setting here, and we need to do more stuff here, but so give you more power as a developer. But the most important part, it was this part here.
Okay.
That when we are in the concept, this is the constructor, this is the constructor of our class. If you call your class home controller, this is our class. The constructor of the class is this function. And as you see, as a parameter, we are defining datetime as a datetime. This is just telling the framework or injector that we need to instantiate this class.
Okay, so datetime is already a class that is known, and datetime underscore datetime is our private variable, and
Yes.
we just assign it to that whatever value.
Yeah. Essentially, this parameter tells the injector to instantiate that service for us, the service that we have here, and just give it to us to this parameter, and this parameter, we assign it to our private property here, datetime, then we can use it in the rest of our code.
But
and call the methods or properties.
so, okay, so where's your main class, or where are you calling this? Or because this is the class declaration, right? So of your controller class.
Yeah, this is our own class. This is our class. Yes, you write this class.
So there's no main method where you.
Not in there is a main method, but the main method is different for web applications. It's not like a desktop application. The main method technically in the ASP.NET or web application frameworks, the thing that it does is just start with creating the application and put it in the web server pool. That's all. And these are the controllers, these are the entry points for your web applications. For example, index page here, I didn't want to go into the details for the web application here, but the index is the one that when you go to your website and you just enter the URL of your website, that's the first entry that actually starts running.
Mm-hmm. Okay.
Yeah.
Shaun, I have a question. As I understand this one, the framework is is instantiating the idate time first
Yeah.
by itself. This is the idea, no? Okay.
Yes.
But it's
Technically,
done by the framework
yes.
automatically. Yeah. But
Yes.
what happened, just for curiosity, what happened if I want to instantiate the idate class and avoid that the framework do for me? Yeah. Just for
Oh,
curiosity.
yes, you can do that if you want. You can just.
It used to say new the idate time, and that is correct.
That's correct, yes. Then that what works too. Is that technically you're not using the dependency injection. You're just going the traditional way.
Okay, but okay, perfect. But could you please go back one slide, please?
Yes, sure. Here or
Okay.
back?
Here, there is a point where we need to implement get heroes, yeah,
Yes.
function.
Okay.
How do you implement that in using Angular? Is at the end you have to implement it, yeah?
Yes, we implemented technically here. Right
Yeah.
now is just one statement because we had a mock data and we just import the mock data and
Okay,
return it.
okay. I didn't see the line. Okay, perfect.
Yeah,
I didn't see the import. Okay, perfect.
That's right. But here you might create a TCP/IP connection, connect to the remote server, and for example, grab the data and return it as a get heroes. Yeah.
Okay.
Yeah.
Go ahead, please. Okay.
Okay, no problem. Okay, so the other things that we need to know about dependency injection is a dependency injection scope. We have three scopes for dependency injection: root level, which is the most popular one, module level, and object level. In the root level, technically, the injector just creates one instance of the dependencies, the singleton, just one object, and give it to every other objects that you have in your program to use it. As I said, this is the most popular one, especially when you have a limited resources, when you have an expensive dependency, like a database connection or network connection, or connecting to the remote server. These are most expensive. These are expensive dependencies. Creating them takes a long time. It has overhead. Lots of codes need to be run outside in backend to make them happen. In those cases, maybe it's better we define them as a root level. The other one is a module level. When we want to make some module, one module, the definition of module is imagine one module as a group of objects or group of classes. In that course, all of the classes related to the one subsystem from your enterprise. In that, if you want to create a independent subsystems to not share anything from each other, the best way is to go for the module level. So in that case, each subsystem has its own instance of the dependency. For example, if we have a sales subsystem and we have a R&D subsystem in our enterprise, and both of these two, they need to have a database connection. You can make a one database connection for sales, and we can make a totally independent another connection just for R&D. So, and you can tell the injector that you need different instance for each module. The last one is an object level. In that case, technically each object or each class that you have then gets instantiated. It gets a new copy or new instance of that service or that dependency. Be careful of this. This one definitely has to be one of these criteria to go for this level. The servicing has to be small, instantiation has to be very, very fast. Doesn't need to have a lots of reserving a lots of resources to instantiate that one. There is a concurrency problem. We cannot share, if there is a concurrency problem, we cannot share one instance between different objects that are running at the same time in the same different threads. So in that cases, you need a separate instances of the service. And this resource definitely has to be inexpensive to create. In that cases, you can go for object level, but usually by default, all of the dependency injectors start from root level. Just in case if you need more independence, you can go for the module level. I really haven't seen lots of case scenario that you need to go up to object level for the dependency injection. Okay. So let's sum up with the dependency injection benefits and dependency injections disadvantage. Dependency injection is the best help that happened to the unit testing. Why? Because as you see, your cloud doesn't have to care or doesn't have to know what this data coming from. So the testing framework, instead of connecting your code to the production for test, you can create a totally virtual environment and connect that one and inject that one to your code for testing your code and keep the production safe. Best help for coupling and best help for cohesion. You are technically taking every code's boilerplate codes that you need to put in your code to instantiate the dependency out of your code. So your code gets really clean and lean. And extending your application easier, because the extending your application is like injecting another dependency to it, plugging another dependency to it. For example, so far your code, for example, didn't have a network connection, so you connect the network connection to your code as a dependency. That's it. So from now on, you have a network connection in your code and you can use it too. And better use of expensive limited resource services that we talk about it, like a database connections and TCP connection. Dependency injection cons or disadvantage. Okay, it's a little bit complex to learn, as you see when I was talking about it. If that was the first time that you are hearing about that, you see that is a little bit different from the way that we are programming and traditionally. Push some compile times to the run times. Push some compile time errors to the runtime. That's you have to be aware of it. The ripple effect of errors. Especially, that's not this DI problem, that's the singleton problem, because if you have just one instance of the object and it fails, so technically all of the programs or all of the objects in your system that use and share that object, they failed. More complex for dealing with the scope of dependency. As we talk about the scope, you need to, in some frameworks like .NET or Angular, you can define that what the scope is. Sometimes creates more confusion or more complexity here. Sometimes a little bit is hard to trace your program because you see the instantiation of the dependency is not in your code anymore. So you cannot trace that part because the framework instantiated for you. And not all frameworks support DI. That's another problem that we are still having right now. And I tried to find some stuff in the 4D. We couldn't find anything. I was not surprised because that's the core architecture of the 4D is that we tight coupled front end or the UI to the database. which goes exactly against what dependency injection is trying to do. So technically, to do that in 4D, probably we need to change some stuff fundamentally in the architecture. For example, we create two versions of the 4D, 4D front, 4D back, with very, very loose coupling from each other. After that, we can introduce the dependency injection in 4D. So unfortunately, I went to the knowledge base and blogs about 4D. I'm sorry, I couldn't find anything for now. And these are the references that I use, and thank you all for listening.
Thank you. Thank you. This is really good.
The concept is clear. The implementation is